All right, we're back. We are COMP397, Web Game Programming, in the fall 2018 semester, and it's week 5, part 1 of our broadcast. We're talking about simple collision detection and response for web games. There are quite a lot of options, but before we get there, one other thing I want to talk about today is GitHub pages. We'll include that one in here as well. But again, before we start, I want to talk about the schedule. So we can see that tonight we're going to have exercise 3. It's going to be due tonight by week 5. It's worth 5% of your final grade, and it's going to be the stuff that we've been talking about in class. So basically, if you hand in your exercise and it works and you know what you're doing, this is your own exercise, hopefully, like the stuff that I'm going to be showing you. You can start from the project that I'm going to give you from lesson 4 from last week. But as long as you hand in a working version tonight, you're going to get your 5%. It's pretty straightforward. Remember that if you don't do this kind of stuff, then on your test, which is happening in week 7, that's 2 weeks from now, there will be some kind of collision detection. And if you don't know how to do this stuff on your own, then you're going to get caught up with it on week 7. It'll be a challenge for you. All right, so let's get going on what we did last week. So last week, we had lesson 4. And just to show you lesson 4, one thing I didn't do is we also talked about our slot machine assignment 1 that's due next week. One thing I didn't do is run assignment 1. I want to run it for you guys and talk about the stuff from last week. So we'll do that too. We'll kind of do that all on this one recording. Hopefully it'll be good. But first and foremost, I want to make a copy of my lesson 4. So I'm going to copy this one. And I'm going to paste it here on my desktop. I know I have a messy desktop. I do apologize. But this way, it makes it easier for us to find everything. Hopefully. There it is. We'll just call this lesson 5. And what I'll also do just to make viewing this whole experience a little easier is I'll change my display settings so that you can see this at 125%. There we go. So we've got assignment 5. I'm going to pull up Visual Studio Code. Right, here's Visual Studio Code. And what I want to do with Visual Studio Code is just pull in assignment 5, just like normal, inside here. We also have a problem because if I press Control backtick, here's Control backtick, and I'm into my terminal. If I do an ls or a dir, I have, well, let's do a, normally I can do ls minus al on a Linux machine. I can't do that here. It's dir/al or dir/a. I see the whole thing, yeah. dir, I want to see all. Maybe it's all. I don't know. I can't remember now. I'm sorry. I'm being lazy. But one thing you can do is if you look at your folder, as long as you showed it, you see that I have a default Git folder here. See this Git folder? So there's 2 things I can do. I want to keep my commits, but I want to get rid of my remote. So I could delete this thing and start a brand new Git repository. But instead of doing this, I want to just change my remote. So the way I can do that is if I'm here, I can say that I can look at remotes by using git remote. I can see that I have a remote called origin, right? And I want to remove it. So I can say that it's git remote remove origin. And what this does is it removes the origin remote. So I can continue with my commit history, my whole development history, and create a new remote. And the way to do that is to say git remote add, and then I can add the origin, right? And then my new repository, which, by the way, I don't have right now. Let's make a new repository. So I'm going to go up to GitHub. Let's go to GitHub. And I'm going to go to, how about Centennial? That would be good. Centennial. And in Centennial, there's going to be a brand new repository. I'm going to call it COMP397 F2018 Lesson 5. And press enter. I'm going to get the remote information right here. I could have just copy pasted this last 2 lines of code, but for now I'm just going to grab this. You can also grab this URI. So I'm going to grab this one. This is the remote information. If I go down here and I right click, it'll paste it in. And if I press enter, it'll add that new remote. So if I press git remote now, you should see origin. Okay. The next line, I'll just type out. It's git push, right? And -u origin master, which is going to push everything that I have locally to my master branch. So if I go back to my new remote repository and I refresh, I'm going to have this this repository. This repository now is going to be the new one that I'm going to be using for today. So lesson 5. So please, for your lab number 3, which I'm going to make by the end of today, which is going to be about collision detection and response, please use this repository as a start. Okay, this is our starting point. Are we good? Okay, before we get started, I do want to show you the stuff for assignment 1. So assignment 1, I told you you're going to make a slot machine. So let's take a look. I've given you the code, but I want to go over what the code looks like for assignment 1, and I want to record what this all means, because some of you are going to ask questions when some people aren't here today. So under assignment 1, which I posted last week, there is this slot machine code base that I gave you. Guys, it looks like this. I'm going to double click, and you're going to get this. Notice there's no user interface. That's your job, to make a user interface for this. How does this silly thing work, right? Well, right now I have a bet of 10. I start off with my player money, which is 1,000. I'm just going to make this bigger, right? With my jackpot is 500. It's pretty low. And if I say spin, then I get some results. Bar blank bow means I lost. Why? Because I have a blank, chances are, right? I also subtracted 10 credits from my money, right? If I keep spinning this, though, you can see that slowly, my money will either go up or go down, right? And you can test out the results. By the way, all these ratio of wins and losses and statistics, I haven't asked for you for doing that. Please don't give me those statistics. I don't care about this. That's for your testing alone, how this works. I'm showing you this so you can see that my win ratio after I've played it for a bit is 8 wins and 22 losses, right? And I have 1,290 credits in my player money, okay? Notice that I have blank, blank, blank. If I keep spinning, blank 7 orange. I spin again, blank, blank orange. How do I get these things? I'm going to show you. Cherry, blank, blank. Blank, grapes, blank, right? And so on until I get a win condition. Notice that here I won because I have grapes, bar, bell. There's no blank, right? So if I have a blank in my particular piece of code that I wrote, if by random chance I get a blank, there's no win, okay? That's what I've done. Let's take a look at the code really quickly. So this is what the interface looks like right now. I want you to use my code, right? That's the exercise. So it's a JavaScript file with a bit of jQuery. Please do not use jQuery in your code. I want you to take it out. Your code's going to be written in TypeScript with a framework that I've given you already, right? Which is create.js. So if I look at the main.js file, it's a mess. But it's not a mess that you can't read. Let's take a look at it. Whoa, man. Look at all these variables. Player money, winnings, jackpot. I mean, it's pretty ugly, right? This part here, show player stats, is just a function that works with jQuery to show me my stats, okay? I have some other utility functions, a reset fruit tally, because I tally how many objects I have, grapes, bananas, oranges, or whatever, and I reset every time I press the button, okay? I also have a reset all if I press the reset button, which resets my player money, my winnings, my jackpot, and so on. Here's my check jackpot, which checks to see if I won. And this is what you were talking about before, Sergio, where I have, I have 2 numbers, random numbers, the try and the win, and if they match, yes, then you win the jackpot. But if it's 52, it's like it's like 2 cards. It's like, yes, it's like almost like I'm pulling 2 cards, and if the 2 cards match, and I think that's 1 in 400 or something like that.
Over 52 square.
Yeah, so it's pretty crazy. Yeah, so it's pretty nuts. The probability is not going to happen every time. It's going to take some time to do it. It will happen though with this probability. And I don't want you to change it too crazier than this. I want to see that it's possible for the user to win the jackpot for testing purposes. In real life, it's like 1 out of 100,000 or 1 out of 1,000,000 or something crazy for the user to win. We don't need to do that here. It's just a test for you guys, right? All right, but the real stuff is not that stuff. It's this. I have this reals method. And the reals method, what it does is it creates a bet line, which is an array of strings. That's what this thing is, an array of strings. And you have there's two arrays, an array of strings, an array of outcomes. Now, all it's doing is when it spins, right, the outcome takes whatever the random variable that I'm going to get from 1 to 65. That's each of the reals. I'm going to do this 3 times, right? So each reel is going to get a number between 1 and 65, right? 1 and 65. And depending on where it is, if it's between 1 and 27 or 28 and 37 or 38 and 46, depending on what it is, and these are the percentages that you can get that, you're going to get some string back that relates to the bet line. So the bet line itself, notice the bet line is going to be a bunch of strings, okay? I'm also going to tally, because instead of using regular expressions, which is also something I could have done here, to make it easier, all I do is tally how many cherries, how many bananas, how many grapes, how many blanks you get, okay? So that's all this does. And then I return the bet line. I return that string, an array of strings back to whatever called me, okay? To determine winnings, if my total blanks, so I kind of calculate how many times I hit blanks or cherries or bananas or whatever, and if my total blanks are 0, somehow I have some fruits, all fruits, right, or whatever, or all symbols, then I won something. Now I need to know what I won. If I have all grapes, I won whatever my bet was times 10. If I won all bananas, all 3 bananas, then it's whatever my bet is times 20, and so on, right? The one that makes the most money, of course, is the 7s, I think, right? If I have 3 7s, so that's up here, 3 7s, then I won my bet times 100, okay? And there's other awards for less options. I also increase my winning numbers, and I show my win message. Else, if I lost, if I got all a blank somewhere, then I show my loss number, increase my loss number, and then I show my loss message. That's what this does. Okay, so pretty simple and pretty ugly code. What I want you to do is instead of right now, what I do is when I click the button, I just spin the reels. I want you to take this code, just the essence of it, those 2 functions, the spinning function and the calculating if I won function. And I want you to incorporate it into your own code as the back end to how your slot machine works. All right? I don't care about the other stuff, the other winnings and calculations of, the other statistics and stuff. That's not for you. That's just for you to see how this thing works, just to see that, yeah, your back end kind of works. Don't worry about recoding the back end to make sure it's perfect. Could I recode this way better? Absolutely. That's not the exercise here. The exercise is, can you make buttons and labels that work in Create.js and use some kind of back end? That's what I want you to do for assignment 1. It's very simple. If you are crazy and you want to revamp the code and make it nicer, go ahead. But you have this one, you have your project, you have other stuff going on. I don't recommend it. If you want to add other code and you want to make it better and get bonus points, you're not going to get bonus points to clean my code up. You're going to get bonus points if you make the reels spin, right? You're going to get bonus points if you make some sound happen. You're going to get bonus points if you have a start screen, a middle screen, and an end screen. That's where you're going to get your bonus points. Focus on that stuff, the stuff that's going to give you bonus. All right? Questions around assignment 1, the stuff you have to do for your slot machine. It's pretty straightforward. I've given you a lot of the working code already. You just have to make your slot machine, your user interface. Focus on your user interface. Okay? All right, but now on to the fun stuff, the stuff that we're doing today. Let's run this thing and see what we've got so far. So I'm going to press Control-Shift-B, which is going to run my watch task. I'm also going to go back to my PowerShell, and I'm going to run light-server, which is going to run my application in my window. This is what I have. So last week, we're able to do my little plane, my island, and my clouds, and they're all in random order with a scrolling background. Okay, so this is where we got to last week. That's not bad, right? This week, we need to do collision detection. But first, what I want to do is I want to put this code up on GitHub pages. How do I do that? Well, let's go back to GitHub. On GitHub, right, you have your code. And there is a settings button. Here's my settings button. If I look at my settings button, if I scroll down, there is an area down here where it says GitHub pages. Take a look at that, right? And it says the source is none. That means right now, it doesn't do any GitHub pages. It's not running. But if I click master branch like this, just master branch alone and save, what it will do is it will start looking at the master branch of this repository as a web page, right? So if I click this little link here, so Centennial College, GitHub.io, and this lesson, right? Notice it says Centennial College, GitHub.io, right? So that's what it does. It actually publishes it into my entire Centennial College page. If I was to actually do that, and I went there, I could see, if I click on this link, if everything went well, I should see my live page happening. Now, sometimes it takes a bit of time for it to propagate, right? So if it doesn't show up immediately, it's because my page hasn't finished propagating. And you can see that in my console, I have failed to load a bunch of resources. For example, my game.css, blah, blah. And what you said was right. My problem is that my pathing is incorrect, right? How do I fix my pathing? Well, there's a problem. My problem is I don't have a node Jekyll file. So I'm missing stuff because inside my files right now, I have a node modules folder. My node modules folder by default for GitHub pages is ignored. It's ignored completely, unless I have a no Jekyll empty file. So I'm going to add that in. I'm going to make a new file called no Jekyll, like this. No, I think it's like Jekyll, like this. And to test that, if I want to find no Jekyll, just to make sure, I can look it up. So if I go to online and I say no Jekyll file for GitHub pages, and I believe it's spelled no Jekyll, like really big like this. So Jekyll. No, it's really, really big. I made it big so you guys can see it. And it says bypassing Jekyll because Jekyll is the server style that it uses, and it ignores node modules. It ignores node modules. I don't have to put anything inside this file. This file can remain blank, and it has to be a .node Jekyll file. All right? So that's what this does. So if I save this, so save, notice the scripts have some stuff in scenes in my play.ts. It says that I have an error somehow in my code, right? How did that happen? Who knows? How do I fix it? That's the most important part. It says I have an error. And it says I'm expecting an extra bracket. Well, let's see how that works. So I've got my module, right? I've got my class. So notice these lines that I can see, my constructor. So here's my class. My class goes down to here, and my modules goes down to there. What's this? So I've got all these extra files. Here's my public, and here's another public, and here's another public, and then I've got a for loop. Oh man, I'm missing a bracket down here, which kind of looks like this.
Well, the problem is you miss the indent.
Yeah. Well, if I do this, and if I go format document, right now you can see that I need this one, and I need this one, the main. I'm missing a bracket for main. That's by default. I don't know how that happened. Maybe I messed it up last week or something. All right. Well, that's okay. I saved it now. I have no errors. And I modified my node Jekyll file. So I'm going to go to this little link here. I'm going to add this little plus button. And I'm going to put a message that says added no Jekyll file, right, for GitHub compatibility. I'm going to click this check mark. And I'm going to click push, which is going to push my files to GitHub. So that's the one thing you need. You need a .node Jekyll file. The node Jekyll file tells GitHub Pages, which is a server that was originally running on Amazon AWS, right? Amazon Web Services. I'm not sure if it's doing that now because it's Microsoft, right? Microsoft owns GitHub. I'm not sure if they've moved over yet or if they're going to. All right, so let's go back to GitHub. Now that I've published that file, I'm going to go back to GitHub. So I'm going to go back to this and refresh and see if it gives me any additional things. First of all, if I go to options, if I go to my Git repository and I look here under my lesson 5, there's a couple things to note. If I click on my commits, you can see this little check mark next to my commits. This little check mark means that it's been published. that the whole project has been published to GitHub pages. That's what it means. However, it doesn't mean that it's going to work. Notice that this is my project on GitHub pages. If I refresh, still getting these errors. But are they the same errors? Right? Are they the same errors? It says Centennial College, GitHub.io, content, game.css can't be found. Well, that's weird. That should work, right? If I click onto that, that should totally work. One thing is sometimes it caches, so I could always try another browser like Firefox. Let's try Firefox. So if I go to GitHub pages, github.com/Centennial College, and if I go there and go to my this one, right? And if I go to my settings, sign up. I don't care about that. Dismiss. Oh yeah, it doesn't know who I am because I'm signing in from this thing. In fact, you know what? I'm not going to do this right here. I'm not going to log in. I'm just going to go back to GitHub pages here. And inside of my settings, it tells me my link. Again, sometimes it takes time to see this little green thing. It's good. That's a good thing. That's a good sign that things are working. I'm going to take this link, copy it. I'm going to go back to Firefox and paste it in, and then try it. And then if it worked, it would work right here. Why would it work? I've got no caching, right? So I know it's not caching or something else. Some other problem is preventing me from working. And if I go into take a look at my my inspect element, and if I go to console here, I can see that loading failed for a bunch of stuff, node modules, and for all this stuff, right? So loading failed for all this stuff. Load modules, easel.js.min.js.
Looking for directly the root of GitHub.
Which, of course, it's not going to work because you can't look here. It's got to work inside of my root. See, it's looking in the wrong root folder. See? So how do I fix that? So let's go back. Let's leave that on. I'm going to go back to my files and take a look at my routing, right? So we got to fix this problem, right? So in my scripts, in my index.html, what am I asking it to do? It says go /node modules, /node modules. That means go to the root of my folder, root. That's what it means, and start looking at node modules. How do I prevent this and do a relative path? Just put a dot in front of it. If I put a dot slash like this, right? So if a dot slash in there, so kind of copy paste for all of those. Now this is a problem later on. You'll see that this will something we may need to change. But if I put dot slash in all these ones, this is going to be relative path. Relative to my current folder, go to my scripts folder. That's what this is saying. Same thing here. And this is the first part that I got to get right. The next part is inside of my script. I have in my core folder, in my game.ts, I also have some pathing, right? That also has to be changed because this is wrong. So there's something I could do. I know that my path is going to be in assets, right? So what I could do, being smart, if I was smarter, is make another variable called asset path, right? And I would change all of them at once instead of what I'm going to do right now, which is just going to put a dot in there like this, right? An asset path would be like dot slash asset slash, and then I would just add the rest to my path, which is a smarter way to do things. All right, so that's the first part. The other part is if there's anything else that I have any kind of pathing. All right, so cool. I've changed all that. I've compiled everything. I got to push to GitHub now. So I'm going to say that. Let's just click that on. I'm going to say updated pathing for project. Right. So that's the next commit. I'm going to click this little check mark. I'm going to go to push, and that should take care of my pathing problems on GitHub. Right. Remember, pathing is a big issue, right? If you don't have it proper, it will never display your stuff on GitHub, ever. All right, so now that that's done, let's go and see if I got my remote. So I'm going to go back to this. I'm going to see that I got 21 commits. I want to see that there's a little check mark here. This is important. This basically says that my GitHub page has successfully built your site. Yay. And then what I want to do is check to see if it works. I'll go back to Firefox, which is a separate thing, and just refresh and see if I get something now. Yay, now it works. So that's actually live on GitHub pages. Okay? So that's what I want you guys to do. I don't want you guys to do anything more than this. If you want more documentation on how to make this work, take a look at pages.github.com. If you go to pages.github.com, it gives you a bit of a tutorial, right? It says, in order for you to make this work, you need a couple things. You need to create a repository. It has to have the name. If you wanted to make it just for your repository, not for a specific, for your whole account and not for your repository, you would follow this procedure. For example, my repository, my account name .github.io. Your repository should be named that. Account name .github.io, right? I didn't do that. Okay, so if I wanted it for all of Centennial College account, I would just make one repo and I would put it up there. Now I've kind of done that for my Tsiliopoulos account, my own personal account, and I'm going to show you that as well. So let me just go there. So if I go to right now, I don't even know if it's running. Tsiliopoulos.github.io. I think it's something else I made. Oh no, there it is. There's the other version of MailPy that I made last semester, right? It works. So this, you can do that too. Also, I have a custom domain name. So if you guys want to go there, you can buy one at GoDaddy or someplace like Namecheap. So if I go to GoDaddy.com, you can get one for as little as $1.99 sometimes. So for example, I want to say my awesome video game.com, you know, I might be able to see that it's available. Yes, my domain is available for $3.99 a year, right? Guys, it's not that expensive to get this done. However, the second year, it's going to be 19 bucks, right? So $3, $4 a year to reserve your name. I highly recommend you get it. It makes your game much more marketable. And if you're going to use it for a portfolio piece, it's okay if one of your members pays $4 a year so you guys have a really cool portfolio piece, okay? Highly recommend. Now for you, you can make every one of your repos little pages like this, right? So for example, for your assignment 1, you can make it, which I asked, on GitHub pages. So you can make your name, let's say my name, Tsiliopoulos.com, so, or Tsiliopoulos.github.io. It could be Tsiliopoulos.github.io/assignment1, and that would be live on GitHub pages, all right? Okay, so that is how you do it. One thing to note, if you're going to have a page like this, which is a default custom domain, let's go to my repo, my personal repo. So if I go to github.com, and if I look at Tsiliopoulos.github.io, which I can get from my profile. So if I look at that, if I look at repositories, and here's my Tsiliopoulos.github.io, you can see that I have another file in there that is not part of my files, other files. It's called CNAME, capital C name. You need this file with the name of your custom domain name inside of your file. So my custom domain name is my last name, www.tsiliopoulos.com. Ooh, it's very exciting, unpronounceable. But I'm saying that's my custom domain name. Is really cheap to get, right? And available. And I put that inside my CNAME file. And now when I point my GoDaddy's domain, if I bought it from GoDaddy or somewhere else, if I point it to my GitHub repo, I need to have this CNAME file, and then I can have my custom domain working. Okay, that's the only other thing you want to add in if you want a custom domain. Questions around GitHub pages. Guys, it's required for your assignment number 1 and going forward for all of your releases for your project. Okay, so all your releases, I want to see it live on GitHub pages. Please be aware of that. If it's not live, you will lose marks going forward for your demo. All right, so please make it live. It doesn't take any effort, really, not too much effort. You already have everything. All you need to load is a .node Jekyll file and proper pathing. That's it. All right, so that's part 1. Let's go into part 2 of what I'm going to be showing you tonight. All right, so I've got my files. Are you good, Sergio? You make it work?
Working for me, but...
All right. Well, you might have missed something, or who knows. I'll go over with you on break. And we'll take a small break. We'll go through this. Okay. So, all right. So I've got these files, but I want to do. We've got our game, but there's no collision management at all, right? One thing I want to do is I want to talk about collisions today. How do we do collisions in video games? There's many different ways. Let's talk about some basic collision detection methodologies. One of them is AABB type collision detection. All right. And if I look that up, AABB, it actually stands for Axis Aligned Bounding Box. That's really, really big because I've made this really, really big. Let's just go down a little bit smaller. Axis Aligned Bounding Box. What the heck is that? Well, if I look at this, I'm just pulling a random site up. What it shows you is some code, yes, but it really doesn't tell you what it is. Let's see if I can show you what that is. Maybe on Mozilla. Look, Mozilla like 2D collision on Mozilla shows you. It has collision, circle collision. It has starting axis theorem. It has a bunch of other stuff. And it also talks about broad phase and narrow phase collisions, which we're going to talk about in a second. But it really doesn't show you a picture of what this looks like. So let's just make one. So I'm going to go into Fireworks here for a second, and I want to talk about different strategies for collision detection. So I'm going to kind of run this thing. I'll make it 640 by 480, just like our screen size. And one strategy for collision detection is overlap, the ability for you to detect an overlap with your sprites, if you will, or your bitmaps. So I'm going to load up some recent files. I'm going to open up my my island. I'm going to open up file, open recent. I'm also going to open up my plane. Hopefully I can get that. Maybe not. I got my ocean, my button. Let's see if I can just open up something else. So open. And yeah, I have my plane. I get my plane, and I'm also going to get my cloud. Okay, so I want you to tell me the problems. I'm also going to open up my ocean. So those three things. So here's my ocean. So if I get my ocean, and I take this ocean, and I copy it, and I go to my untitled, and I paste it, I have this. So that's what the thing will look like, right? And if you look at my island, let's take my island, and I copy it, and I go back to my untitled, and I paste it. Yay. And I have my plane. So I take my plane, I copy it, and I go to back my thing, and I paste it. Yay. All right, so cool. So let's see this thing. So imagine if you have your plane, and it's running along, and the ocean's falling down, and I want to do a collision. AABB collision says that if I have some kind of overlap in my code, that means I check the top left corner and the bottom right corner and the top left corner, top right corner, bottom left corner, bottom right corner, and anything that's in there that overlaps between one rectangle and another that are aligned from an axis perspective. That's why it's called axis aligned. That means both my, let me just make my ocean unmovable. Both my island and my plane are on the same, use the same axis, X and Y, all right? They're axis aligned in this case, right? And if I was to see if there's a collision here, and then when they overlap, there's a logical collision, I can register a collision. Yay, there's a collision. That's how it works. Axis aligned bounding box. However, my friends, this has flaws. And one of the flaws, especially if the objects, what if the objects are not shaped from a rendering perspective, square? So if I zoom in, right, you can see that this one has a little bit of space down here, right? The bounding box for the bitmap looks square, but down here, actually, I'm not square. Did I hit right here? Look at the visual collision. Am I hitting visually? No. But am I hitting logically? Yes. This is the problem with axis aligned bounding box. However, I have to say that in very small situations where there's like really fast collision detection and it's this close, like there's not a lot of pixels between the spaces that are going to overlap like this, it's probably going to be good enough. Now, here's where it's not good enough, all right? This might be good enough, but what if, and I don't have this situation, what if I was going to collide over here? Is this good enough? I guess really far away, right? You can see that's not like really close at all, but look, that's a collision. And in fact, that's a collision too. How about this? Right? Look, this is not a collision, but what if I make it like this? That's a collision, right? That's really bad. It looks like I'm colliding, but I'm not, right? Sorry, it doesn't look like I'm colliding, but I am. Like logically, I'm colliding. You can see that the two bounding boxes are intersecting. But visually, I'm not colliding. So from a player experience, it sucks. Sorry, right? If you see objects colliding with axis line bounding box and they're so far away, it's not a good result. Okay, so this is one possibility. Here's a really much more extreme one. Okay, so this is bad. But what about when you have clouds? So here's my cloud, and here's my object. Let's make it a little bit more pronounced. My clouds have way bigger objects that are like way bigger areas of space. And now look at it. That's not a collision. But in the game, it would be a collision. Because logically, it's colliding. And this isn't so bad. But this, my friends, is really bad. I'm colliding here. But I'm not colliding. Visually, I'm not colliding. But the shapes are so massive that I am, right? And if I really want to be extreme, I can pull this shape even further out like this. And I'm still colliding. I'm still colliding, right? That's really far away for me to have a collision. Would you agree? Do you think that's okay? That's really far away. I'm colliding there because I have my boxes. I'm just trying to see if my bitmaps overlap, right? Bad. And even worse if up here. If I somehow had a collision happening up here, I'd be colliding up here all in the space. I can fit my whole plane in there. Look, if I took my plane and I put my whole plane in there, I'm colliding and I'm inside the entire area there. Right? But I haven't collided a thing. It's not even colliding, right? Lots of space like this. Irregular shapes like this, axis line bounding box, doesn't work. Okay. However, in some cases, when objects are really quite small and square and they take up the whole space, it makes sense. Like, for example, a tile-based platformer, right? With everything that's squarish. It's okay. Axis line bounding box is the lowest cost. It's not very bad at all. The other way to do it to handle this problem is with something called separating axis theorem, okay? Which to me is like really overkill. It basically states that if there's an axis that's separating the two objects, right, then there's no collision. If I can separate the two objects with an axis, for example, is there an axis that is there a line I can draw between these two objects? That's what it means. If there's a line that I can draw between the two objects, there's no collision. In this case, by using separating axis theorem, there's no collision. However, I'm not going to go into the code because it's a little bit out of scope for what we're doing. The code and the complexity of what you're doing, so it's not like O to the 1, right, or anything crazy. It's like, I think it's O to the O quadratic, something really crazy for it to happen. Separating axis theorem is great for simulations, okay? It's not great for video games. It's not great unless you want really good accuracy, right? You need really good accuracy, and you have a lot of, I'm going to tell you, calculations you can do every frame. If you can do really a lot of calculations. For example, if you're running C++, then separating axis theorem in a C++ OpenGL environment might be okay, right? However, we're running web. We're on a web game. We're running, at the end, JavaScript on a browser. And it really depends on the speed of your machine that's receiving. Separating axis theorem may not be the right solution. Okay? There's also other solution types. Like, for example, instead of axis aligned bounding box, you may not have an axis that's aligned. So there's alignment that's there when we're not aligned at all. Like, for example, if these things are somehow rotated like this, now the axis is not aligned, right? You have an axis that's this way, and if somehow my bitmap was rotated this way too, and if it's not axis aligned bounding box, there's another kind of collision detection you can use as well. But which collision detection did I recommend? For now, it's called either circle detection or circle collision detection, where you use a radius around an object to detect if something collides, or distance checking, which is really what we're doing with circle detection. All right. So the way to do that is I want to draw an invisible line between the middle of my object and the middle of the other object. Okay. Oh, that's a really big line. Let's make it, yeah, an invisible line. Let's suppose this black line is not visible, right? And we're saying that, okay, so if the distance between these two objects is less than half of the radius or sorry, the radius of the objects. If it's less than the radius of both the radius of the objects put together, so radius of object A plus the radius of object B, if you can take those two radiuses, and if it's less than those two radiuses, then you have a collision. So I'm adding the radius. So it means that I have a circle. I can imagine an imaginary circle, right? So let's just draw it. So here's a circle, right? And I have this, imagine the circles here around my plane, and I have another circle over here. Let's do it again. Now you're going to see a flaw on this one too. Here's my circle, and I have my circle around my cloud, and if it's less than half the radius of these, if the distance is less than the radius of both of these two circles added together, I have a collision. Why? Because if I take this object and I move them closer, that means it's the radius, the circles are touching, right, or less than touching. Then that means that I have a collision. And then we get to this part, right, where we have this problem right here. What happens here, right? Again, we have the same weird axis-aligned bounding box circle issue, right? Now you could make the circles tighter. So instead of like making it as wide as this, you can make them so they hug the object a little bit more, right?
We can divide the object in 3 cycles.
You could do that. You could divide the object in pieces, but then every frame you're going to check each of those pieces separately with my player ship every single time, right? That means there's going to be 4 checks instead of 1. Mm-hmm. So that's 4 times the calculations. So we want to reduce calculations as much as possible.
You can do like nested, like have one like encompass it.
Yes, and then we
randomly check if it's inside.
If it's inside this, that's another way. So that's called broad phase, narrow phase collision. So we can have a broad check like this, and then we say, okay, it's inside the circle. Cool. Now let's do another. Let's slice the circle up into quadrants, right? And if it's inside this circle, right, then it collides. Or check again. We can do a recursive formula where it keeps colliding and colliding and colliding, or what we call quad trees. You could use quad trees, right, and do that. And in 3 dimensions, you'd use octrees, right? Yeah, it's pretty crazy, right? Octrees and quad trees, which is a recursive algorithm that checks if it's inside this circle, then check and see if it's inside that one, and check to see and if it's inside that one, finally, then you're colliding. And it almost gives you perfect, pixel perfect accuracy. But performance-wise, not the greatest thing. Again, I'm doing multiple checks for every object. I don't recommend for a little game. So what we're going to do is we're going to simplify it, and we're just going to do a distance check. But instead of doing the entire circle, we only care about, because our game is up and down, all we care about is the height. If I take half the height of my objects and compare them, and the distance between the 2 objects, in this particular case, because they're scrolling up and down only, I'm good. I'm probably going to be good enough. And you guys got to get to the point where you're good enough, okay? The other thing is, I do never, ever, ever want you guys to try and do pixel perfect collisions on a 2D game. It's the worst in performance and the highest in complexity, all right? There are ways of doing it. You can do it with CreateJS, but it's really computationally expensive. Please don't do it, all right? Do some other kind of collision detection system, right? So I'm talking about this because there's a lot of controversy around this stuff, right? So part of this is lecture, but I also want to think about some other problems. Tunneling effect of bullets. Okay, let's talk about the tunneling effect of bullets. So imagine if I have this little ship, where I have this little circle that I have around it, and I'm checking for collision between myself and an enemy bullet. All right, so let's make another circle, and let's suppose the enemy bullet is this. Okay, let's imagine that this enemy bullet, I'm just going to draw it red or yellow. There he is. There's the enemy bullet. The yellow part of the bullet is my actual bullet. All right, it's traveling, let's just say very, very quickly down the stream. It's traveling, in fact, 70 pixels a frame. 70 pixels a frame. Okay, so I'm going to link these 2 together. I'm just going to group them, right? Oh, not those ones. This one and this one. Let's just group them up so that I don't have to worry about this. So there's my object. This is traveling 70 pixels a frame. So in frame 1, I'm here, right? And in frame 2, I'm here, right? Do I have a collision? Yes. In this case, I do. But what about in frame 1, somehow I'm here. And in frame 2, I'm here. Do I have a collision? No. It passes right through. This is called the tunneling effect of small objects moving very fast, right? It's a problem. It's a problem with games that you have fast-moving objects. It doesn't matter whether it's 2D or 3D, right? If I have an object moving really, really fast and really, really small, it could tunnel through because of the time when I start checking, depending on how many times I check. So what I could do to master this is check a frame ahead. Check a frame ahead. So first of all, do I have, am I going to get a collision next frame? Okay, cool. But is there an object that's in my path? That's the thing. And what you can do, and I've seen this done before, is you can draw these feeler lines, if you will. So something like this, some kind of feeler line ahead of the bullet, right? So right now, I'm going to collide, right? And chances are, unless the player moves, I'm going to collide, right? Next frame, I'm going to collide, right? And you don't have to do it so far away. You can do it a lot. Like I drew it big, like a really long thing. But something like half the length of the speed of the object or something like that. There's a mathematical formula where you can actually check. It doesn't solve the problem, by the way. It actually creates other problems too, right? Because what if I'm really quick and I move out of the way and I register a collision anyway, right? So that's a problem because I'm moving so fast and now I don't have a collision yet, but I'm going to register a collision because guess what? I'm so close that I'm going to be probably colliding with this thing. There's probably no chance the user can move out of the way. And this is, guys, trial and error. You have to arrange for that extra feeler, that extra little ray, if you will, and you have to keep trying it over and over again. But you need to do 2 checks for every bullet. One check to see if you're colliding with the feeler, and another check to see if you're colliding with the bullet, right? It's computationally expensive, especially if you have a bullet hell shooter. When I have 1,000 bullets on my screen, now I'm going to do 2,000 checks every frame. It's a lot. So be aware of these problems that can happen with bullet hell shooters, right? So solutions: make the bullet bigger, make the bullet slower, but more bullets, right? Make the objects bigger, right, on the screen. I'm just saying, those are things, those are standard little solutions you can make, right, without doing extra checks. Or sometimes accept an occasional tunnel. Those are things you have to think about. Which one are you going to accept, right? Because sometimes the computations that are involved to make it perfect are almost impossible. Okay? It doesn't matter what collision detection method you use, by the way. Even if you use AABB collision, same thing. If I have AABB collision here, and then I check here, it missed, right? Okay, let's get back to the actual work. Are we good on collision detection? Okay, there's no response yet. Collision response for us is going to be, we get some kind of points. We're going to move to the game over screen. That's what we're going to do. In a physics game, collision response can be very complex. We could have a bullet bouncing, or some kind of enemy falling, or something like that, or some kind of force being imparted on the other object from the one object that's colliding with it, right? But that's not what we're doing here. All right, so I know I want to do distance checking. I need something that is going to be something that I want to reuse from one level to the other. And if I want to reuse it, I need a class, right? Because I don't want to link it only to one scene, if you will. So let us make a new manager. That's what I'm going to make, a new manager class called Collision Manager. So I'm going to make a new manager, new file. We're going to call it Collision to start preparing. My Collision Manager is going to basically be a singleton, all right? It's going to be a public static. It's going to have a public static interface for my, my collision check function for now, okay? So I'm going to put it in my module managers. And inside my module managers, I'm going to export a class, which is going to be called Collision, my collision class. I'm going to have some private instance variables. I'm going to have maybe some public properties. For now, no, I'm not going to. I'm going to put it anyway. I'm going to have a constructor, maybe some private methods, private, and maybe some public methods. Well, I'm going to put my public static method down there, right? I know that my collision manager, I'm not going to instantiate. In fact, I'm just going to use the public static method that's going to be called check. Collision managers.collision.check is what I'm going to make it, right? Think about my module as a namespace. So I'm going to make this public static. Public static means I don't need to instantiate an object of type collision. I don't need to do that. And I have access to this function that's floating inside of my manager's module, right? The function is going to be called check, right? And it's going to return void for now.
Capital letter?
Sorry?
Not capital letter?
If I want, I can make it capital. Let's make it capital just to keep with the same stuff we've been doing. So check, collision.check, sure. Typically, we would make it capital. All right, so capital check. And you know what? Before I add anything, I just want to add it to my code. I want to go back to my index.html, and I want to look at my code. Where should I add this thing? Okay, I need to know about my player and my cloud, my player and my island. I need to know those things. So chances are, because I need to know those things, they need to go somewhere down here, right? I need to know about these things. So collision's got to go down here. Even though my managers are up here, I can't put my manager down here. So this manager has to, my collision manager needs to know about these things that I'm checking, or at least about game object anyway, right? I need to know about game object, so it needs to go down here before scenes. So I need to go something like this. So this is my managers. Again, another area. Continued. And I'm going to put a manager in there, which is going to be a script. Later on, we can avoid this kind of stuff, right? Which I'll show you how to do that when we build our file. Ooh. Script source. Again, just to follow the convention of pathing, // right? So it's going to be scripts, and then it's going to be inside managers, and then it's going to be inside collision.js. So now I've connected my collision manager class to my file. If you don't do this on your test 2 weeks from now, and you add your own custom class, you'll never, ever be able to access it. It'll give you, there's no constructor. That's what it's going to say. All right, or some other error. All right, so now that we've done this, I want to go back to my collision file and see how this collision thing would work, right? So I have my collision check. My collision check is going to be using some kind of distance checking method, right? Oh man, do I have a distance checking method in my math for JavaScript? Does not exist, right? I need a utility that's available anywhere in my code in order for me to check the distance between two objects. And then if I need that, I might as well need some kind of vector, you know, something to kind of keep track of positions, right? Luckily, CreateJS has something called the point class. So if I look at the CreateJS point class, so if I go CreateJS, and if I want to look at documentation, so here's my docs, and if I look under docs, if I look at my easel.js docs, there is something called a point class. Here's my point class. So CreateJS point, right? What it does is it defines a new object of type point. It gives me two properties, x and y. So I have the makings of a new vector, right? So there's a couple of things I want to do. I want to create a vector2 object, a new vector2 class. My vector2 class will hold x and y coordinates and have a public static method that allows me to check the distance between two vectors. Okay, that's what I want you to do. So how do we do that? So this is another class we're adding in for my collision manager, right? To make my collision manager functional, right? Now, do you have to do it this way? No. You can put a massive line of code that looks like this. If somehow I got to make another thing that checks collision, right, between A and B, then if the distance is less than half the widths, then you have a collision. But what if I want to reuse this distance checking method again in the future? For example, if I want to know the distance between two objects for artificial intelligence or something else, right? I may need to do this. So where am I going to put this vector class? Do I have a module that I could stick it inside? Well, it's not really config, and it's not really core, and it's really not managers or objects or even scenes. We need another thing. And I'm recommending that we make it either a math or util. So let's make it into util. So make a new folder or call it util. Make it small. You could call it utilities if you really care about making it whatever you want. It's up to you what you would name this thing. I recommend util. And I'm going to make a new file called vector. All right, so I'm going to vector util.vector. So I'm going to make a new file called vector. I'm going to specifically tell you it's a vector2, a vector2.ts. The reason why I'm going to make it vector2 and not vector by itself is because maybe we might have need for a vector3 or vector4 or vector whatever. I don't want to rejig this thing. I just want to call it vector2. Again, module pattern specifies I need to put the keyword module, the keyword util, right? And inside my util module, I'm going to export a new class that I'm going to call vector2. My class is going to extend, right, the create.js point class. All right? I don't have to do this, but I'm going to do it. I have some private instance variables. I have some public properties. By the way, you can make this really cool, this little util class. You can add all kinds of other math calculations like lerp, slurp, and dot product, cross products, matrices, magnitude, all kinds of stuff, which we're going to do. Private, public, constructor. We're also going to have private methods and public methods. Now, this is tiresome, I know, but it kind of sets up our structure for all of our classes, so everyone knows what they are. All right, do I need a constructor? In this case, maybe I want to make it so that I can create a vector, a new vector, right? So I want to make a new constructor. Maybe my constructor is going to take a couple of variables. I need to call my super constructor, by the way, by default. My constructor maybe is going to take two things, x and y. Okay, so maybe I'm going to have an x, which is a number, and y, which is a number. Now, this is exactly like the point class. So far, it doesn't really do anything for us. But let's make it so that by default, we assign a value of 0 to x and y. So if they don't otherwise specify, my vector2 object will take x and y or nothing. And if I specify nothing, it's going to give me x and y at 0. So what I'm going to do is I'm going to pass in x and y here into my point class, right? So whatever they are, if it's 0, it's going to be 0. If it's something else, it's going to pass into my point class.
So if point doesn't require x and y, they're optional. What do they give them by default? They tell them?
No, they give you zeros too. But I'm specifically specifying. I'm being explicit in saying if someone doesn't provide something, it's 0. This also allows me to do other things. All right. Let's make my public static method that's going to be, we'll call it distance. You could also call it magnitude. Public static distance with a capital D. So how does my public static distance work? Well, I need to take in a vector, right? I need two vectors, vector A and vector B. So I need to go here. And what it's going to say is, so vec1, let's say vec1, is going to be of type util.vector2. And vec2 is going to be of type util.vector2. Uh-oh, wait a minute. We're trying to define a new public static method called distance inside of my vector2 class when I haven't really finished defining it. Can I do that? In JavaScript? Yes, you can. And so too in C#, Java, and a bunch of other languages. All right, so now what this is saying is my public static distance is going to take two things, a vector2 and vec1 and vec2. And what I want to do is I want to return something. I'm going to return a number. What number is going to return? I'm going to make it in one line. There's different ways to do this. I'm going to use square root. Okay? This is square root. Square root is a very computationally expensive operation to do every frame. I'm just telling you. But for now, for us, because we're going to have so few objects, it's going to be okay. All right? We're just going to accept the square root. Later on, we can think about other methods of doing non-square root, like squared distance. The squared distance without using square root, right? So I can square the distance, and I can also square the range. So my half width will be the half width squared. If I compare the half width squared of the two objects, if it's less than half the square of the distance, right? So without doing square root, it's the same thing, right? It works out to be the same. And it saves us calculating square root. For now, we're not going to do that. We're just going to say return math.floor. Math.floor. I love it. Math.floor. And then math.square root of. We want to do math.power. You can also do first thing times second thing. Math.power of my first number. So vec1.x, or we'll say vec2.x minus vec1.x all squared, right? Plus math.power vec2.y minus vec1.y to the power of 2. And that, my friends, will do everything you need in one line. Wait, could I do this differently? Could I do this differently? Absolutely, I could. And why am I doing math.floor? Because remember, we're going to get an absolute pixel. We're not going to get some portion of a pixel. We're not going to get 0.2 pixels or 0.3 pixels or something like that. I don't want that. I want full pixels, integer numbers that I get back, right? And that's what this distance formula will do. It'll take two vectors, vector 1 and vector 2, and it'll return back the distance between the two, the Euclidean distance, if you will, or the Pythagorean distance between the two objects, because we're using the Pythagorean formula. C squared is equal to A squared plus B squared. That's what it is. Okay? And in this case, we're going to take the differences from one vector to the other, right? Subtracting the distance, and we're squaring the distances on the x component and the y component. Okay, cool. So that is definitely one public static method. And if I want to, I can document it with document this. So I can do something like this, document this, and I can say something like this method returns the, we'll call it Euclidean distance, same thing, Euclidean distance between vec1 and vec2. I think that's what it does. All right, so that's our distance formula. Could I stop there? I could. I could stop there, but we're not going to. What if I want to do some other operations, like addition? I don't have overloaded operators, unfortunately, in JavaScript. Doesn't exist yet. And Node2 doesn't also exist in TypeScript. So what I could do is I maybe want to add two vectors together, right? I want to add this vector to this vector to get the other vector, right? If I want to do that. So maybe I can make some other public static utility functions. Public static. And I can say something like add, where I take vec1, which is of type util.vector2, and vec2, which is, again, util.vector2, and I return a number. Would I return a number, or would I return a vector? A vector, because I'm adding two vectors together, right? Which I return a util.vector2. That's what I return, okay? So I could do it this way as well. Now, this is more complex. I'm waiting for two vectors to come in, and then I'm creating a third vector. So I'm going to say that result. So I'm going to say something like let result, which is of type util.vector2, equal to the x's and y's added together, right? So I'm going to say that a new util vec2 object with x's. So with vec1.x plus vec2.x, and then y's, vec1.y, right, plus vec2.y, right? So that's going to be my object. That's my result. And I'm just going to return the result. You can see that there's lots and lots of things I can use here. I can make a lot of little vector functions to help me with kind of adding things, subtracting things, and so on. And I'm just going to document this. Which I'm going to say this method returns the resultant vector of when adding vec1 and vec2. I don't know. And you can make something like this. This method returns the result of vec1 and vec2. And I might as well do the same thing with subtract. So I'll kind of copy this and paste down here. And instead of add, we'll do subtract. So I can subtract the vector. And you get the point, right? So where I say instead of this, I just subtract. Now, this is interesting. Do I subtract vec2 from vec1? Or do I subtract vec1 from vec2? Depends on what you want at the end of the day, right? So if this is initial and this is final, initial and final, right? If this is, and instead of calling it vec1 and vec2, we can rename them like start and destination, right? That kind of thing. It's up to you. But for me, for now, I'm just going to say that when you put the first one, you subtract it from the second one. So I'm going to just put the subtract symbol in there. But you could be more careful and define it differently. So I subtract vec1 from vec2, and I can just put another comment that says this method subtracts vec2 from vec1, right? And returns a vector 2 results. Again, you could phrase it the way you like. I think this is probably better than the first thing I tried. And you can do other ones. You can do other things where if I want to have a public static method that returns, up, down, right, left, where up means something, it returns a vector that's up, or I want to return 0, I can return a vector that's 0 as well, right? So I can do a bunch of stuff like that. I'm going to leave that up to you if you want to have additional utility functions to help you. For example, if I want a vector to move in the right direction, right, then I'm going to have 0, 1, where 0 is x on the, 1, 0, where 1 is to the right of the on the x-axis, and 0 is nothing on the y-axis. That is right. That means right. And if I return -1, 0, that's left. So why would I care about that? Because I can multiply the vector. I don't have a multiplication function, but I can multiply the vector by a scalar and have a number of units that I'm moving to the left or the right, right? Based on, right, left, or up, down, whatever I want, okay? Now, I've gone a little bit off topic because I've made some additional public static methods. All I really care about for our case is this distance formula. That's all I care about. So let's attach my vector to my, my project. So I'm going to go back to my index.html. And now I got to think. So my manager depends on collision. Does my util, does it matter where I put it? It just needs to be above manager. I like to put my utilities way up here because you know what? Chances are other things might need them. So something around my config files is where I like to put them. So because config, my collision manager will need to know about it, right? So this is my util files. So utility functions, if you will, or classes as well, if you want to make classes. So I'm going to attach it here. So /scripts/util /vector2.js. There's my vector2. Are you with me? Do you understand what I'm doing? Right? I'm doing this to prepare for collision detection, right? So what I'm going to do is now that I've got the vector2, I added a shell for my collision class, but I haven't written it yet. I'm going to go and say, I'm going to add all this to GitHub. I wrote my vector2. I'll say added vector2 utility class. Right? And then push. So now you should have that code, the utility vector2 class. I haven't tested it, however. I don't know if it's going to work. Right? We may have to modify it. All right, cool. Now that we have my vector class, and it does a couple of things, maybe one of them that's really useful, the other one's not so much right now. I'm going to go into my collision manager, and now I can start using my detection, my collision detection in here. How do I do that? Well, I want to not check only check. I want two things. I want two game objects, and this is new. I want to make sure that the objects I'm checking are game objects, right? So I want to say object1, and I want to check, right, with object2. Object2 is of type of game object, objects.gameObject. And so is object2, objects.gameObject. So I'm checking between the distance between two objects. I'm collision checking the two objects. That's what I'm doing, object1 and object2, right? So that's number one. Are you with me? All right. Next up. Now that I have my two objects, right, I need to create my vector1 and vector2. I don't have vectors right now, right? Remember, my collision detection uses vector1 and vector2, right?
Oh, we can add a method in the game object.
I could add a method, but that means that I have to keep track of my game object, my vector, to every frame. I have to update it every frame. If I do that, if I add a vector2 position object, let's say object1.position, object2.position, and my position is a vector2, x and y, then I have to update my position every frame. Is that where you want to go? I don't mind.
No, it's a method, no an attribute.
Well,
So
it might make sense, right? Because I could create a vector2 object for my game objects. That is part of all my game objects, right? But then I have to check every frame. I have to update my position every frame. That's what I have to do. So every frame, I'm going to just update those numbers, update those numbers, update those numbers, okay? So it might be more computationally expensive, but it could be a convenience method that I create. Or I could ignore that, which I recommend because it's extra calculations for now. We can think about that later. And I want to make vec1, right, equal to my a new util.vector2 object, which is going to be my x and y coordinates of my object1, object1.x and object1.y. And similarly, I'm going to make, every time I check, still going to do the same thing. I want to point this out to you, right? Is this less computationally expensive than actually including this part right here inside of my game object? Less or more? What would you recommend? Remember, I'm going to do my collision check every frame. Every frame, I'm checking my collision, right? Because I need to. I'm not doing broad phase, narrow phase right now. I'm just checking every single frame. So for now, if you think about that, that means 60 times per second, I'm going to generate new vectors, new vector1 and vector2, every single frame, and I'm going to assign values to them every single frame. And then I'm going to dispose them every single frame. So I'm going to create them, instantiate them, and I'm going to delete them every frame. Is that less or more computationally expensive than including a vector2 object that I update every frame inside of my game object superclass? Which one do you think is better? I already have x and y positions, right? I give it a hint. Instantiating any object is computationally expensive every frame. If I instantiate new objects every frame, it's computationally expensive, even if objects that don't render, right?
We're only ever going to have two vectors here, and we keep them as statics for collision itself.
But then what if I want to check between one? I mean, I would never have to create new ones. There'd be public static. I could do that inside my collision class. So in my collision class, I create 2 new vectors, public, static, and then what they do is they update.
Yeah.
That's all they do. I only create them once, right? However, that might cause other problems later when it comes to calculations, because I might check the vector 1 and vector 2, and I might have another problem. My recommendation, guys, is we don't do it this way. I could. I'm just putting it up there. I could create some temporary game objects right here and then dispose about them every single frame. But this is happening every frame. Anything that happens every frame is computationally expensive. And I think if I was to do an analysis, that it'd be cheaper for us to do this inside the game object, to create almost like a transform in the game object that we can update. So let's not do that here. Let's come back to this. So if I go back up to the game object superclass, which is inside of my objects, and if I go to my game object superclass, let me think about this. Do I need it for every object, every single game object? The answer for you should be no. I don't need it for every single game object. I'm never going to check the distance between my buttons, right? I'm just being honest. And this harkens back to what we talked about a couple of weeks ago, which is, do I need another subclass before my game object, like an actor, non-actor, right? If it's an actor in my game, then it's going to have some things that my other game objects don't have, right? And so I can further subclass a game object that is not an actor and a game object that's an actor. For example, an enemy or a player. It's different than, and maybe a platform. And it's different than a non-actor, right? Which is like a button, still a game object, but I'm never going to collide. And it doesn't need a lot of the other things like half width and half height and all those other things. I don't know, right? For now, though, we're not going to optimize because we don't do optimization right now. All we're going to do is add it on, baby, right? So we have our instance variables. I have X and Y. We're going to make a new one called position. Private. I'm going to say position, which is of new util.vector2. So it's a new vector2 object, right? And what I want to do is I'm going to make a getter and setter, just like I've done in the past, right? Where I can say that get, and I'm going to call this position with a capital P, right? Which is going to return a util.vector2 object, all right? And I'm going to return this dot underscore position. That's what it's going to do. I'm also going to have a setter where I want to set my position with a new value, some new position, which is going to be of type util.vector2. And what it's going to say is that this dot underscore position is equal to new position. And it's giving me a error. It says that set accessor cannot have a return type annotation. Oh yes, special case. I got position, get position, and set position. Great. But position has never been defined. So in my initialize method, just like I've done with get bounds, I'm going to say that this dot position is equal to a new util.vector2 object, where I'm going to pass in the initial this dot x and this dot y values, whatever they happen to be at the time, right? Chances are 0, 0, right? Because remember, my object has this x and y. It has x and y. It's built into all display objects, right? So I can always know the position of my object. Okay, now I'm changing this on the superclass game object, which means all other game objects are going to have the position vector, all of them. Okay. Now, so this is happening on initialize. Okay. But now I got to do something else. Inside of my any objects that I want to update the position on, that means any of my enemies and my player, I have to update the position every frame. Because my position is only happening once. It's only getting defined here in my initialize method and never being updated. That means if I initially assign them as 0, 0, it's going to stay 0, 0 forever. So I have to update my position every frame. That's what I told you. Just like doing the other thing we did with collision. But I'm not instantiating the positions more than once. It's only going to happen once. My player is only going to have ever one position vector, right? Okay, going back to my player now. So I've updated this thing. Yes.
Why do we need to create an attribute for the position? Is not better to only to return the position and make the vector only when we call it? We have the X and the Y.
But then if I make the vector every time I call it, I'm instantiating and deleting. Remember I talked about this?
You make it if it's not there already. You do if position.
Uh-huh.
If not position, then
Uh-huh.
create.
And when am I going to create it?
You do it in the else for that.
But when am I going to do it? Am I going to do it only for objects that need it?
Yeah, whenever an object
Like, for example, like
whenever an object receives a call that would require it to furnish position,
I can create it. Yeah, I could do that. I mean, that means that if that's optimization, guys.
Okay.
Yeah, but yes, you could do that.
So today is cheaper.
Yes, you could do that. What you're saying is better. But however, there's a better method even than that. Like I told you, to further subclass, which means that maybe there's going to be some form of game object that doesn't need its position, right? That doesn't need some of this stuff. A specialized game object that's only like a button or something that doesn't care about collision checking or whatever. And therefore, I'll never, ever have that, right? Make sense?
If we're going to have to add stuff to update in all of our subclasses, is there any way to make it so that
I can do it here? Yes.
Yeah.
So, but that means that my update method is not going to be abstract anymore in my game object superclass, right? That's the only way to be done, right? I'm just saying. So then I would have to make this change, right? And it's not going to affect anything downstream. However, because I'm overriding the update method downstream, right? I'm overriding the method, right? Then what may happen is that this original method may never trigger, which means my update will never happen.
oh, you
You'd
don't
have
need
to
a super
add
call, right?
the super.
Super update. Like I have to call the super update anyway, right? I mean, I'm just telling you that's something that I have to do, right? So I could call the super update, or I just could add it to my enemies and so on. Again, an optimization might be make a actor subclass that does it, right, for me, right? For now, let's leave the game object superclass alone, and let's go back into my my two actors, my three actors that I have. I have a plane. Here's my player, and my player. What I want to do is every frame I want to update. So I want to check not my X and Y position, but also I want to update my location. So my position. I'll say that this dot position, right? And again, I can update individual members. For example, I can say that this dot position dot X is equal to this dot X, and this dot position dot Y is equal to this dot Y. I could do that every frame. Or the better method would be I can make a private method, which I think is best. Let's make it a private method. So these are some public methods. Here's a private method, private, and I could call it update position. Now this is something that I could add into my superclass, right? I could add this one into my superclass, which does this. So it does this, right? That is something I can add into my superclass. However, instead of making it private, I'll make it protected, like this. And if I took this protected superclass, this protected method, I'm just going to cut it out of here and go back to my game object superclass. And inside my superclass, add that in as a private method again. What I can call it, because it's protected, I can call it from my subclasses, right? Then I don't have to write this every single time, which means I'll save some code. Okay? So if I go back to my player class, I don't have it in here. I don't have it in my private player class, but I can call it in my start method. In my update method. So my update method, I can say that this dot update position, right? It actually updates the position of my object every frame. Does that make sense? Are there other ways to do this? Absolutely. There are other ways. There's optimizations we can make further down the line. For now, let's make sure it works. All right, so this is this. And now that I have that, I can do that for all my objects. I can do that for my island, we're on update. I can just, before I call move, I can say this dot underscore update position. So I update my position, I move, right? But do I want to do move, or do I want to update my position inside the move method? Maybe I want to do it there, because first I want to move my object, and then I want to update my position. So I kind of hide it in here. That makes sense, because I want to move first and then update, not update and then move. So otherwise, I might be a frame behind.
It also is last on update.
I could do that if I want to. There's a lot of other things I could do, but right after my move is fine. And I can do the same thing on. I'm just giving you options, guys. You guys can decide how you want to structure your, your code for your final game, for the way your game works. Okay, so now I've updated my island, my cloud, and my player. Do I have to do this for my ocean? No, because my ocean does not care about position. It's just going to stay 0, 0 forever. Because I don't care about the position of the ocean. I'm not updating on the ocean. Could I? Yes, I could, but I'm not, because I don't care about it. I'm never going to check collision on my ocean. All right, so this is something I could do. Notice I'm also doing this move method where I'm moving, but the move method is different, so I can't inherit it. It's always going to be different, because vertical speed and horizontal speed for my cloud, and I have my vertical speed and only for my island, and for my player I don't even have a move method. Not for now. All right, so we're good. Now we can go back to this. Do I need these things, vector 1 and vector 2? And the answer is I don't. Now I can just do my check, right? So I can eliminate this stuff because I don't need it. But I could do something like this, an if statement. If, right, I'm going to check my collision on object 1 and object 2. So I can say that if the distance between object 1 and object 2, right, is less than half the height of object 1 and half object 2 combined, then I have a collision. So if util.vector2.distance, right, and I put in my vector for vector 1 and vector 2, which is just object 1.position and object 2.position. By the way, I did this differently last time. If the distance, right, is less than, right, and I like to put less than, not less than or equal to, by the way, because I like it to be less than, not equal, because then it's not really a collision, chances are. Less than the distance, I'm going to put the total heights. So game object 1.half height plus object 2.half height. Now you know why I saved half heights. And before you didn't know why, now you know. If that's true, then console.log collision. Yay, collision detection. That's what I want. You agree? So far, that's what my check function does. Is that enough? To check collisions. To check collisions. Because it doesn't do anything, but it checks collisions. So is that good? Can I check? Can I see if it works?
Why not return true?
I could do that, but let's just think about this for a second, right? I could return true. All I want to do is check to see if, when I work, guys, I work to see if my method works. If my method works, I can add other conditions, I can return things, I can do whatever. The first thing I want to do is I want to check to see if this thing works. All right, so good. So I've passed in, I've got all my structure. I have to do all that structure to structure everything so I can do this thing easy, so this thing doesn't look like a pile of mess. That's why I did all this. Otherwise, I could create objects every frame, and then I wouldn't have to do vectors. I wouldn't have to do any of this stuff, right? But going with my previous experience, this is the better way of doing it, okay? It's less messy, right, and less tricky. You look at it, you understand what it means. In fact, maybe you want to say, check if object 1 is colliding with object 2. That's really what this is doing, right? And if it is, we get a collision. Let's see how we can make this work, though. So inside of my play scene, that's where it's happening. So I'm going to go to my scenes in my play scene, right? I have this structure, right, where on update, right, I am updating the ocean, updating the player, updating the island, updating the cloud. I want to check to see if my player collides with the island. Let's do that first. So it would look like something like this. It's a static, right? So I can say something like managers.collision.check, and I pass in my player, right? So this._player and this._ island, right? So now I've checked to see if my player and my island collide. Check if player and island are colliding specifically, right? Would you understand how this, does that make sense to you? I'm running a public static check method that's contained in my collision manager, right, to check to see if these two things are colliding. All right, I could return true here, like you said, if they're colliding, right, or not. Let's just do this for now. All right, let's try this out and see if it works. So I'm going to go back to here in my game, and here's my stuff. I'm going to pull up my inspector, and I'm going to go console and run, and I only care about the island. So if I go island, I get collision, but I don't get collisions with my clouds, right? Because I didn't check collision. But if I go island, oh, but wait, there's a problem. Look at all those collisions I'm getting, man. Woo! Why is this happening? How come I'm getting all these collisions?
Because it's doing it every frame that you're colliding. Yeah.
All right.
That's good behavior, right?
That's good and bad. It's good because I programmed it this way, but it's bad because I'm checking every frame, but I already know I'm colliding. So I should already have done something. I don't care about colliding every single frame with my island. I want to collide once, right? After I'm done colliding, then I can start colliding again, right? Same thing with my cloud. If I did the cloud, I'd be colliding. I'll lose lives every single time I flow through the cloud, right? Like multiple lives, not just one, right? I want to only lose one life when I flow through the cloud. This is my condition, right? And I want to only gain 100 points when I fly over the island one time. What do? I need a flag, right, is the answer, that checks to see if my island or my cloud is colliding. I don't want to do it on the player because my player can collide with multiple objects at the same time. I could collide with my island and my cloud and something else, a bullet, all together in the same frame, okay? That I could do. But I only want to check if my island is colliding with one object at a time. It doesn't care about the clouds. All it cares about is checking with player every single frame, which means, going back to the drawing board, in my game object superclass, I can have another instance variable called isColliding. So this is called isColliding, which is going to return a Boolean, right? Does that make sense? And then I'm going to make a getter and setter. So get isColliding, which is going to return a Boolean. I could say that return this._isColliding. And then when I set it, same way, set isColliding. Oh, I called it isColding. isColliding. And I want to say that this._isColliding is equal to, oh yeah. We'll say new value again, which is of type Boolean, right, is equal to new value. Okay, so that's my getter and my setter. I'm just adding those in. So my get accessor method and my set mutator, okay, those are the two things I'm using. isColliding, I made my isColliding method, and again, I made my private instance method, member called isColliding, which is a Boolean. Question, should my collider, can I make my isColliding static? If I do, that means when one object collides, all of them collide. Right? That's what it means. Right? Now, in my initialize method, I want to say that when I initialize my object, this dot is colliding is equal to false, right? I don't want to, it's not colliding in the beginning, right? I make it, when I'm brand new, I make my brand new island or ocean or whatever, I want to initialize my objects as false. They're not colliding, right? Does that make sense? Let's take it one step further, all right? Let's take it one step further. I also have something else that I want to keep track of. I want to know which object I'm colliding with, right? I want to know if it's a cloud or an island. Okay, and now good thing is that all display list objects in create.js have a name string. It's just part of the class, right? So what I can do is for my player, right? I could, when I instantiate my player, I could say that when I construct my player, actually, you know, I could say that in the start method that this dot name is equal to player. I could do that. I could say that when I start, or I could do it here where I want, right? This dot name is equal to plain, let's say, or player, or whatever I want. And I can do the same thing. And there's a reason for this, and I will discuss in a second. But again, these are creational choices that you may decide you don't want. I'm just putting it out there because this is something you can do, and this is a fix for some things, right? So in my start method, I could say that this dot name is equal to hold on, and there's another way of doing this too. From my cloud is a cloud, right? But is there a way to do this in my superclass? And the answer is there is. I don't have to do this, right? I always want to record the name of my object. And if I record the name of the object, as an example, as the name of my bitmap, then I'm good to go, right? I'm good to go. So how do I record the name of my bitmap? Well, I'm already capturing it. So if you notice up here, when I go to my constructor for my superclass, I'm passing in the name of my image, which is the name that I can capture, right? So I could say something like, okay, fine, I'm passing it into my superclass, but before I initialize, I could say something like this dot name is equal to image string. And that will do it for all objects that inherit. And this is a great thing because I'm keeping track of the name of my image. And typically, the way I name my images, they're all the same names. So my image is called plane, my image is called island, my image is called cloud. Nice and easy, okay? So those two things I need, and now I can go back to my collision class, right? So now that I know this, I can say that, okay, if my distance is whatever, I'm colliding. So I could say that my object 2, if that's true, then this dot, sorry, then object 2 is colliding is equal to true, right? Because I just collided. Nope. I don't care about the colliding for player. Hear me out. Not yet. My player is not colliding with anything. My player, I could state that it's colliding, but for now, let's leave it so all that's colliding is object 2. Later on, I'm going to check for object 1 and object 2, right? But for now, let's leave it as 1 because later on, I want to show you what we have to do, right? I want to really, you know, kind of explain everything, Pedro, right? Otherwise, what's going to happen is you're going to say, oh, yeah, we already did this. But we're doing it knowing what's going to happen ahead of time, and I want you to explore what possibly could happen if you forgot to do this. I want to kind of explore this thing a little bit more. So please bear with me. I know it's okay to do that here, but let's not. Okay? So all we care about is object 2 is if it's colliding. But what about if it's not doing this? If this distance fails, then I know that object 2 is colliding is equal to false. I know that's true, right? If it's not colliding, if the distance isn't true, then it's not colliding, right? Okay, cool. Well, if it's colliding, if it's already colliding, right? If it's already colliding, I don't want it to check collisions. I don't want it to do this anymore. I don't want to do something with it every single frame. I don't want to check collisions if it's already colliding. Does that make sense? I don't want to check collisions if it's already colliding. Why would I do that? I can save myself a check that includes the square root. I want to do that. I only want to do this collision check if it's not colliding. So I can say that if object2 is colliding is equal to false, or not object2 is colliding. You can write it either way. Typically, I don't like to write things in negative, but I'm going to put that in there and format my selection. So I can say that, hey, if object2 is not colliding, then check collisions. Oh, did it collide? No. Then my object2 is colliding is false. Is that okay? So I'm checking to see if it's not colliding. If it's true that it's not colliding, I check to see if it's colliding, right? And if it's, when can I ever put this as false? This way. Think about it. It won't work if I did this, right? It'll never be false. It'll always be true, right? Because once I go here and I say this is true, then it's colliding, right? And if it's colliding, it'll never come in here. So this is wrong. Does that make sense? So what can I do differently? Come on, help me out, guys. I can't do this because this will say, well, check to see if it's colliding. And if it's colliding, then it's not colliding anymore, right? You know, kind of thing. And I don't want to do that. So what's the other way I could do this? Come on, guys. Sergio, what do you think? How could I reword this thing to make it more valuable? I want to do this check, this is colliding thing. But let's think about this. So I check my distance, right? As an example, it's going to collide, but I want to see if it's colliding. So can I put this in here? So cut. And I want to put this in here. If not object2 is colliding, guess what? Now I can say that object2 is colliding. Is that okay?
We want to save the...
We can't save the distance in this case. We can't save the distance check if we do it this way, right? But this works. Is there a way to save the distance check, right? By knowing that object2 is already colliding, and when it is colliding, set it to it's not colliding anymore, right? And I want you to think about this. This is logic, right? So here right now, I'm going to say that I'm going to use this one. So I'm going to say, well, if the distance is right, it's within range to collide, but I'm not already colliding, then I am colliding now, right? And guess what? I want to say that I'm colliding with a specific object. So console.log, right? Console.log, backtick, right? I can say colliding with, and then $, curly brace, object2.name, right? Because I know that that's the object I'm colliding with. Does that make sense? So I'm colliding with object2.name. But only when I'm not already colliding. Let's figure this out. So I go in here, check my collision. Okay, I'm colliding. Cool. My distance is right. Cool. If my object2 is colliding, no, it's false by default. Well, now it's true. And now do something. Okay, now let's go back. Next frame. Check my distance. Okay, if my object2 is not colliding, is that true? No, don't do this. Leave. Go back, check the distance, and keep doing that over and over again. Check the distance. Check the distance. And when it's outside of range, then this is false. It'll keep checking until this is not true anymore, that I'm outside of the collision area, right? So it'll check every frame. Okay, let's check and see if this works. So start. So I want to collide with my island only once. I want to collide with my cloud. Wait, did I check my cloud?
No.
Okay, my island works though. Look, I'm only colliding once. Once. But what about if I do this? What about this? Can I do that? Right? I can. I can do that for sure because That makes sense, right? I'm colliding more than one time. I'm leaving and going back, leaving and going back.
Yes, you're
every
counting
frame.
how many times you entered to
That's right. I'm checking how many times I'm entering. I'm not checking if it's something that I've taken or something. So for now, this is okay. The way to prevent that, of course, is if I have keyboard controls that slow me down, right? So I can't do that kind of thing. I can't go, right? You know, or other things.
Invincibility frame.
Invincibility frames. There's a bunch of other things I can do, right? But for now, this is okay. We're going to make sure we've got collision detection. I want to pick up some points. And if I assume that the player is not going to do, right? If I assume that, if I can make some assumptions for today, right, then this is okay.
You could also add some kind of value onto like the island class.
I could.
So when it resets to the top of the screen,
then I can start colliding again,
yeah.
right?
Oh yeah, you could only update the colliding
on reset. So when my island is not, so basically that's another thing I could do. I could say that as soon as I'm colliding, then don't check collisions anymore. Because if I'm already colliding, I'm going to reset myself to the top of the thing. This is the way we can stop checking distances, right? I don't have to check distances if I'm already outside until I reset. That's going to be a much better situation. I was hoping not to get there today, but thank you for that. That means that is going to solve our problem for a bunch of stuff, right?
At this point, we're specializing collision to be very about the island.
Well, we can do this. It'll be the same thing for the cloud, right? If we make it work from the island, we can make it work for the cloud. You'll see. So let's fix that. So this is right. So yes, I could do it this way, but I like Wesley's solution more, right? Which means that I want to put this outside the check. I want to put this check outside, right? And the only time this is false, is when I reset. That is way better. And it's a way better solution than this, right? So instead of doing this, right, let me just copy this and put it up here, right? So I'll still do this. I won't do this part in here or this part in here. I'll just do this part when it's colliding, right? This makes sense. But now I got to surround this part. I can't fool around like that by taking this and copying it into here. Oops. Take that comment too. All right, so now I can do this, and then the only time that I reset to false is when I reset my position. So what I can say is, now I got to think about this. Does anything else reset? My island and my cloud reset. So I got to go in my island, and in my reset method, when I go to my reset method, I'm also going to set this is colliding to false. So this is colliding is equal to false. And I do the same thing for my cloud, just to remember that. So I'm going to go to my reset. Now this is a superior way of doing it because it saves me the check every frame. If I've already collided, I'm not going to keep checking for that particular object for more collisions. I'm already collided. You already damaged me. I already got points. Let's wait till the reset, till the new object comes in. Then you can tell me if I'm colliding again. Much more safe. All right, so that's true. That's good. Let's see. So that says it's a false. And in my collision manager, the only time I check this is if it's true. I check in here. So I say that when I'm colliding, that object2.isColliding is equal to true when I come in here for the first time, right? As soon as I come in here, it's colliding. And it's not going to reset to is false until it resets off the screen. That's what's going to happen, which saves me this whole check.
But object 2 is the player.
Object 2 is the island or the cloud. The player is object 1.
Okay.
Now, remember what we said from before, Pedro? Why I didn't want to check with object 1 yet? Oh, there's other reasons too. All right, so let's do this. So we've checked the distance. Let's see if this works for the island. I'm going to go back. I'm going to start playing. And now collision. Okay, how about this now? 2 collisions, but I can't get multiple collisions no matter how much I try. I only get 1 every time the link comes in, no matter what happens. Great. Now let's do it for the cloud. How do I do it for the cloud? Well, the cloud is a special case, again. because there's more than one cloud, I need to check for each cloud. Well, I just told you what to do. For each cloud is when I'm going to check. And that's going to happen, might as well happen when I update my cloud array, which is already happening right here. So I'm going to put inside this for each loop, I'm going to check collisions as well. I'm going to say that managers.collision.check. I'm going to check that this.player and this.cloud are colliding. But not this cloud, but actually cloud. Because I'm inside a for loop. That make sense? So I'm checking on my island to collide and for my cloud to collide. By the way, now you can make it more efficient, right? Now that I have the ability for me to check collisions with those two objects, later on I can go and optimize. This is where you have to go to before optimization. I can check to see if I can get a collision, right? Cool. Let's try this out again. Going back to this, start, then I should get cloud, 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 cloud. Wait, how come it's not colliding, cloud, cloud. I've got two clouds there. I got a bunch of clouds. I got a cloud there. I got a cloud there. I got a cloud here. And looks like we're okay. It looks like we're colliding only once, right? With each, wait, what happened there? Look, did it collide? Cloud, 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 cloud. Okay, good. Well, it'd be great if we had some feedback, right? That every time we collide, we get some sound. And I've already preloaded my sounds, so how do I get that feedback? So let's do it like this. Let's say that in my collision check method, now I want to tell you something about, first of all, about sound.js. Sound.js creates static objects that collide, that make sounds for the entire game. Not for that scene, but rather for the entire game, my entire instance of the game, right? So when I make a sound, I always make that sound. So here's how I could do that. I could say that object 2 is colliding, right? I know that for sure. But I could check to see which object it is. I could say that let's switch on object 2 name, right? Case if it's island, then do something. Case if it's cloud, then do something else, right? And I can have a default case too. All right, and if it's island, I can say that, well, sound.js, right? So I want to make sure that my create.js.sound.play, and I can play the yay sound. Yay. How do I know it's that? Because in my core, I specified that yay means the yay sound, yay.org. I don't know if you remember that. To show you this really quickly, I'm going to go into my core. Let me just kill all these editors for now. Let me go into my core. So here's my core. And in my core, in my game.ts, you can see that yay sound is the yay sound. Okay? Let me just go back and fix that. So I made a mistake. It's not yay, but actually yay sound. Yay sound. Right? The yay sound. And if I hit my cloud, create.js.sound.play, and then it's the thunder sound. Thunder sound. Okay. This is instance. These are static instances of these objects, right? I'm instantiating the sound at this particular point in time, and then it's being destroyed. Okay, so then you know how it works. So if I go back to my core.ts, the game.ts, I can see that it's called thunder sound and yay sound. I also have something called engine sound, which I'm going to make in a second. Let's see if this works. So I'm going to save this. I go back to my scene and play. And I got nothing. Wait.
Yay. Yay. Yay.
Oh, man. What happened?
Yay.
Look, what happened? Huh?
Yay.
I'm not getting anything here. Let's refresh. Actually, it's my whole browser window, right? Can you check to see if I'm still broadcasting? Somehow back. We had the same problem last week, but for a different reason. This week we were bad because my computer crashed. I don't know what happened there, but I do apologize. Let me just finish this off here, and I've got to do some stuff. I got Discord going on. Everything just kicks off again. Let me just bring back my folder from the thing I was doing last. I had a lot of stuff opening. Maybe that was the problem. But you know what? It's okay. It's okay. So this is the project that I had open. Luckily, the great thing is this: I can always kick off or download stuff from GitHub if I miss something, and I've been pretty good. There we go. This is where we were last. I'm pressing Control-Shift-B for this thing to make sure that it has my build task running. I'm not letting it rest, eh? I'm attacking it already with stuff to do. My Visual Studio. Look what it says: fetching build task, which is never supposed to say. It's supposed to be instant. And the same thing goes with my. I'm going to add another PowerShell, which is light-server. Let's get back there and see what happened. All right. Let's see if it's going to crash me again. So yeah, what I was I was here.
Yay. Yay.
Well, that was weird. Did you hear that? That's, yeah. Oh yeah.
Yay.
What's happening there?
Yay.
So something's happening. Look, I'm even colliding. Way here. Oh, that's bad. Why is this happening?
Yay.
All right, let's refresh.
Yay.
First of all, let's take a look at my inspector, and let's look at my console. Now, why would this be happening? So, cool, I'm good, right? And I'm colliding with things that are not even there. Look. Why is that happening? Look. Come on, tell me why this is happening. Well, I know what the problem is. I know what the problem is. The problem is not with my island. My problem is with my cloud. Did you notice? There's a reason for everything. It does what I tell it to do. Remember that the programs and the stuff. First of all, let's put up this code because I don't want to kill my computer dies. At least you guys have everything, right? I'll say added basic collision detection. And we have a bug we have to fix, and we're almost out of time. Actually, we are out of time, but bear with me while I fix my bug. It wasn't having a problem until I started playing my noise, my sounds, right? When my sounds started having a problem, you know, as soon as I play a sound, it has a problem. All right, so let me go back to that. So if I go back to my managers, I know that it's something to do with these checks. So let's go through the logic here. So if my object 2 is colliding, then is not colliding, then I can check the distance. And if the object is colliding is true, then I want to make the sound, yay sound or thunder sound. That's what I'm doing, depending on if it's an island or a cloud. So that's the only time it checks. All right, that's the first thing. Are we still good? Is everything else? Let me just check to see if there's not an error over here. Object 1 and object 2. This is good, right? And let me see if I did something else wrong, right? So I'm going to go in. Also, the other place I did was I checked it in my game.ts, sorry, in my game.ts, in my play scene, sorry, my play scene. In my play scene, what I'm doing is I'm saying that every frame for every cloud, that's constant.
Oh, ho, ho, ho.
That's why. That makes sense? See that little check? That was my bug. My bug was that it was creating a constant value for clouds. And actually, we had a bug all along. We had a bug all along because it was constant. That cloud was a public static equivalent, right? It was constant inside that loop. Same cloud. And I don't want this. I wanted for it to be for every cloud, right? So just to make sure, and again, this is the for each cloud in, right? If it would work again, let's see if this works. So first I'll save it. I go back to here, and let's go here.
Yay.
Good. Whoa. Good. What happened there? Look, I should have collided.
Yay.
I collided again. No collision. No collision. No collision. No collision.
Yay.
Double collision.
Yay.
One cloud, have collision.
Yay.
Yeah. The third cloud doesn't have a collision.
Yay.
See that? You see that? We have a problem. It's very subtle, but there's 3 clouds, and one of them doesn't collide. That's a problem. That's a real problem. And I really believe it's this for loop, right? Because this for loop checks for every cloud in clouds. So which means that we know that every cloud in clouds is being updated because they're all moving, right? We know that that's true. And we know that I'm adding all the clouds at the end. For each cloud, oh, that's a problem, man. That's a real problem. They know what that is. It's not a copy paste error. That is an error in this code. So I'm getting mad, right? So I want to do my for each, my classic for each, which is this. This works all the time. I use another kind of for each to be smart with you guys and say, hey guys, it's really cool when you can use a for each loop that looks like this. But this actually is cleaner for me, right? Where I can do one of these and get rid of this form. Remember I talked about different forms of doing a for each loop? In this case, this is the best way. And just to be clear, I'm going to do the same thing here because it makes me nervous to see that effect where I do my cloud update. So instead of this, I'm going to cloud update, cloud.update. It's a bug, right? I don't like bugs. I don't like bugs at all like that. That is a bug in JavaScript, or maybe it's a bug in TypeScript, but I don't like it. I'm getting an error here, which means I probably don't have enough curly braces.
No, it's you let the for.
Oh. Are we good? Yeah, I feel better with this one. Let's see if that makes a difference. Same thing, right? It's just cleaner. And there's no consts, which makes me happy. Start.
Yay.
That was weird.
Yay.
Error is still there.
Yay.
Something's not right.
Yay. 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 Yay.
See? It's like,
Yay. Yay. Yay.
it's like something's not happening. It's like it's a bug. It's like every time it's working for the islands, but for the clouds, something or another is happening where it's not resetting that particular thing. It's not setting it to false upon reset. So that's the problem. The sound is not crashing us anymore because we don't have any consts in there, right? But something is happening with that other cloud. Something is happening. We can see the effect, right? I got 2 out of 3 clouds working, and I don't know why, right? So why would you think it's a problem? Do you have any clue? Let's have some leads, right? So
It starts throwing around a lot of console logs at this point.
we could start doing that. Or, and this is what I recommend even more than that, we could do some debugging. Have you seen, did I do the debugging with you with Visual Studio Code? Let's do the debugging with Visual Studio Code. How do we do debugging? First of all, you need to download an extension, right? So there's an extension called the debugger, which is the debugger for Chrome. Please download that. Okay? If you don't have debugger for Chrome, never going to work. And then, when I download the debugger for Chrome, after I download it, I'll give you a second to do that. What I want to do, and I'm almost done here, guys. I'm going to be done collisions today, okay? But and next week we'll do UI and points and all that stuff, okay? But I want you to think about this for a second. Let's think clearly, right? I have everything I need, right? But somehow it's not working. That means there's some place where the value of the object, because every object has its own identifier, if you will, at the end of the day, memory allocation, right? On the stack, every object is messed up. So where, if I was going to put a breakpoint in my play scene, where would I want to put it? I'd want to put it here, right? But I'd want to put it on the collision checker here every time I come to playing this sound. So when I play the create.js, my cloud sound, this is where I seem to miss a step. It's almost like I need to know what my object is. So let's do it here. So every time I come into my collision checker, I want to know which one what my game object 2 is. So I put a breakpoint in the gutter, which is right here. Next, I want to look at this little debugging icon. And on the top, after I've installed my Chrome debugger, I need to click this plus button. When I do, it's going to ask me what kind of debugger do I want, and I want Chrome. Then it creates this little thing here. Now notice it says localhost 8080. I'm running on localhost 3000. So if I was to run this thing, typically for me, it wouldn't work. It looks like this. If I click this little button now, it'll run another browser on localhost 8080. And typically for me, it fails like this. Okay? However, what about if I run the thing on 3000? So I change this little code to 3000, right? And if I run this now on 3000, I know that I have a thing running on 3000, right? Okay, let's start. It says Acrobat added. Sure, I'll enable this again. Start. Cool. Now it's stopped. Here's my debugger running in Chrome. Okay. If I go back here, I'm here at this point here. Here's my thing. Here's my my point, my first breakpoint. It's happening every frame. Okay, it's happening every frame. This is a lot to deal with. But here's the thing I want to show you, my friends. Look, take a look here. First, it's object 2 and object 1. So if I go back to this, and if I look at my local and my global, right? And if I put these windows up and down, right? So here's my watch window, and this window here is my local variables and my global variables. Let's not look at global variables, but my local variable has a context for this, and it also has object 2, which says it's an island. It tells me a lot of information about it. Half width, half height, and height. It also tells me vector positions. Look, vector positions. It tells me properties, visibility of true, rectangles, a bunch of stuff. Vertical speed, WebGL render style, if any, and blah, blah, blah. Lots of stuff. And here's my vector 2 position, which is 598 minus 558, because every frame, I'm basically passing along my X and Y values to it. And further down, I have X and Y's, which should be the exact same, 595 and 58. Are they the same? Those have to be the same, because if they're not the same, we're going to get a slip in collisions. Okay? But you know what? I don't care about my object 2 being island. I want to check if it's cloud. So now I'm going to step out. So now it's back to this. Now I'm in my cloud. I'm in my cloud checker. Okay? So notice my local is the play class, right? Here's my play. I'm going to step into or step over. Now I'm inside of this object is colliding. Here's my object is colliding. I have my cloud. Here's my first cloud. And if I go into my cloud, I'm just showing you where you can look, guys, all right, to give us our information. Here's my listeners. Here's my width. And if I scroll in there, here's my image, a blob. That's why I was telling you the blob for my image. I have my is colliding right now. It's false, starting off, right? My parent is play. My position is my vector 2. And my regex, my reg y is 0, 0. Here's my position, 152 and negative 172. Negative 172 is off screen. It's way higher than the screen. That's where it starts off. Okay? And then scale is 1. Scale x and scale y is also 1. Here's my stage, my width, and my height, and so on. Okay, so where can I check for more information about this thing? Well, if I go to Proto, it shows me that I've got my vector 2, my constructor for this one. This is my vector 2. I don't care about that. We're ID. ID is 6. Guys, this is it. Here's my ID. I want to track this ID. So for ID number 6, right, as an example, that is my cloud. That's my first cloud, ID 6. Why is it ID 6? Hello. I'm checking through my loop, and it's number 6. Ocean, player, island, cloud. But that's like 4, 5, 6, right? Well, why am I checking 6 first? Just checking. Why am I checking 6 first and not, 4 or 5? Guys, there's a reason for all this. right? All right, this is good. I want to step back out. I'm stepping back out. I'm going back into my for each loop, right? So I'm going to go back into it. I do my cloud update, and then I go into my managers, and I'm back to this. So here's my cloud, and my ID is, which is really what I want. What's my ID? My ID is 7. Remember, each object has a unique ID, right? My ID is 7. Great. Step out. Step back in. Manager updates. Go back to my cloud. And my ID is 8, right? So I have 3 IDs. But it goes 6, 7, 8. Okay? Is that okay? Where the heck is, the other ones, right? Stage maybe is something else, but there's other objects that are happening that are here, and I have a few IDs, 6, 7, 8 on my clouds. Huh?
These are the previous buttons get preserved of the button.
Right? We have to know. I don't know. Right? This is the information we have to go with. Guys, I'm going to leave it to you. I want you to figure this out. It's not a big thing, by the way. Here's a question. Could it be that I'm using a for each loop? Because a for each loop is checking for each of the clouds in my object. Did I instantiate my clouds properly somehow? Right? Or did I not? There's something that's going on which one of my clouds is slipping. It's almost like it's not checking for that particular cloud, right? At all. But the good thing is I want to show you this debugging stuff because sometimes you're going to have a bug like this and you're going to use this. This is the variables. Down here is the call stack. For those people, do you know what a call stack is, first of all? A call stack is any method that we have right now running on the stack, and it happens in reverse order. So here's my collision check. There's some anonymous function that was called, and then update, and then update, and then some anonymous function, some kind of dispatch events, my ticker. And here's this is my ticker and update, right? So these things, my friends, is really, really good to know because it tells you the time, right, that it was put on the stack. Okay? How long? So this is what I wanted to show you guys. It's debugging, and you can do it inside of Visual Studio Code as well as Chrome by itself if you want to. Guys, thank you so much. Remember that next week your assignment 1 is due, which is before you go. Slot machines due by the end of class next week on Saturday. And remember also that I will be checking your status of your game every week going forward, right? So I'm going to talk to you about your game. I want you to show me your updates, even if nothing is due that week, okay? Guys, thank you so much. I'll see you next week. This is good for you for a start. And my challenge is find out why it's happening to me. Tell me why it's going on, okay? And we'll talk about it next week. I have a clue of why, by the way. Let me just, let me be off screen.
We need to submit this.
Yes.